So here we have ethylene, and we're preparing it by heating hexane at 800 degrees. The hexane C6H12 or H14 is going to break down. It's going to produce ethylene, C2H4, and other products that we're not interested in. It says that the yield of ethylene production is 42.5%. So in this case, they're giving us the yield. What mass of hexane must be used to produce 841 grams of ethylene? 481 grams of ethylene, sorry. So this is a type of question that you might have as a process chemist, because some reactions are well characterized and scientists know how effective they are at producing product, and you might need to produce a certain amount of product of a certain amount of substance for sale. You need to make this stuff so your company can sell it, and you know that the best reaction you have to make it doesn't even really have a very high yield. So you want to back calculate how much reactant you need to put in if you want to make a certain amount of product. So if we have a 42.5% yield, so we know the formula for percent yield, actual over theoretical times 100. So in this case, the percent yield is 42.5%. The actual amount we want to make is 481 grams of the ethylene. And actually, I don't need that. What we're looking for here is the theoretical, because they're asking us how much hexane do we need to put in? How much of the C6H14 do we need to put in? So if we want a relationship between how much product we're going to make and how much reactant we need, and we're not going to be able to get 100% reaction, we have to account for what the theoretical yield would be, and then recognize that we're only going to get 42.5% of that theoretical yield. So if we're given the percent yield and we're given the actual yield, we want the only thing left in that formula to solve for is the theoretical yield. So we can rearrange that formula to solve for theoretical yield. It's going to be 481 divided by 42.5 times 100. And so the theoretical yield I need to shoot for is 1,132 grams. So I know that I'm limited by both of these to 3 sig figs, but maybe I want to keep an extra sig fig for now so that I don't round until the very end. So basically what we just determined was, if I set this reaction up with enough hexane so that theoretically I should get 1,132 grams of product, if my percent yield is only 42% and I only get 42% of that, I'll end up with the targeted 481 grams that I need to make. That's what we use the formula, the percent yield formula, to tell us. So then I could set up a conversion. I could say, if I know that my theoretical amount of product is going to be this, how much hexane do I need to put in to make that? Or how many grams of hexane do I need to put in if I want to try to make 1,132 grams of the product? Recognizing that only 42% of that amount of product theoretical is actually going to be made, that will give me enough to sell. So again, I have information about one substance. I want to convert it into a different substance. I've got to go to moles first. So I need the grams of C2H4 to moles of C2H4. So 2 carbons plus 4 hydrogens gives me 28.05 grams per mole. So then, the whole point of that was so that I could cancel moles of this substance and get moles of the other substance. So before I can really cancel that though, what numbers do I need to put in there? Normally I have a balanced reaction with specific coefficients here, but if I have something that I don't know what it is, how can I really balance that? I can't, so that makes it very difficult. So let's see what the question says. It doesn't say anything about that. So I guess we're meant to assume that the other stuff that's created accounts for the other 4 carbons and 10 hydrogens to balance the reaction, and that this really should be a 1-to-1 ratio. In reality, I wouldn't want to make that assumption because I don't know. I would hope that the question would be written with enough precision so that I know how to balance the reaction. Otherwise, I can't do this question. So I guess we'll assume for now that the ratio is 1-to-1. But on an exam, I would probably, instead of giving you an incomplete reaction that you can't balance, I would give you a complete reaction with all the reactants and products that you need so you could balance it and use the coefficients from the balanced reaction in this relationship to make it equal. So then if I have moles and I want grams, for that substance I need its molar mass. So 6 carbons plus 14 hydrogens gives me 86.17 grams per mole. So that will cancel here. Got the units I want. So for my final answer, it's going to be 86.17 times 1132 divided by 28.05, and I get 3,477. But I remember from before I had only 3 sig figs, so I've got to round that to 3 sig figs, so it'll be 3.48 times 10 to the third grams. So that's how much hexane I would need if I'm predicting only a 42.5% yield and I want to make 481 grams of ethylene. Assuming that the reaction ratio is really 1-to-1.